Continuous struggle with compliance and trying to explain why. There's a forecast. Say, it doesn't matter if it's only Cat 2 instead of Cat 4.
Start with this.
If they say, oh, it's not, it's just like,
So,
in a sense, like they're overstating. No, they overstating. People don't buy it. People know there's a difference, that's why they're staying there. So
starts on the 6th. This actually is basically the whole life cycle of solutions in this. Can it be rewound? It'll loop. If you pause it when it starts. Okay, good afternoon, everyone. We'll begin Weather Watch today. On Weather Watch today, we're going to focus initially on just the past week. We'll look at the track of Hurricane Florence. We were talking about that at Weather Watch last week and talking about the very likelihood of an impact or possible impact landfall along the East Coast last week, and now we're actually seeing the impact. The impact occurred, or the landfall occurred early this morning around 7 a.m. our time, 8 a.m. Local time near Wrightsville Beach, North Carolina. It came ashore as I think a strong Category 1 or a weak Category 2. I don't have that bit of information directly in front of me, but let's go back to a week ago. Weather Watch, a little bit just before Weather Watch last week, we were looking at the cyclone well to the east-southeast of Bermuda, well-developed cyclone, and we'll just track forward in time to see how it all developed. You can see in this IR imagery, it was strongly sheared last week during Weather Watch, and over the weekend, sort of got through the shear, began to intensify, and became, in fact, a very strong Category 4 storm by the early part of this week with a well-defined eye. If you could pause that for a second. It had a really well-defined eye, and then it underwent a process that perhaps Professor Tripoli might want to chime in, talk a little bit about, but it underwent a process that very intense tropical cyclones often undergo, which is so-called eye wall replacement cycle, in which the eye wall is a solution of strong, intense convection, strong winds just outside of that with so-called radius of maximum winds. When you get these eye wall replacement cycles, you see a concentric eye wall that forms much further out from the intense winds and gradually contracts inward, eventually sort of suffocating the interior eye wall and eventually replacing it. And during that time period, when the inner eye wall gets suffocated, if you will, gets weakened because it doesn't have strong convection in it, the storm begins to weaken and it has to reorganize itself as this new interior eye wall begins to form, and then the whole process starts all over again. The timing of these, I think, are kind of tricky, but there were a lot of indications a week ago from microwave imagery that you're actually seeing a stronger eye, a secondary eye wall forming, and people were predicting some 12 to 24 hours in advance that this would occur. It actually did that, but in the process of doing that, it never seemed to quite recover from that. It was a strong Category 4, then began weakening to a Category 3, all the while the Hurricane Center was anticipating this to actually re-intensify, and it just slowly began to weaken. Some possible impacts of that or effects of that were the fact that it was undergoing some weak shear during that period a couple days ago. And with shear, one of the impacts of it isn't just destroying the hurricane vortex, but it's also the arrival of drier air that surrounds these tropical cyclones. It's sort of characteristic of the tropical and subtropical atmosphere. That shear can help sort of to ventilate the circulation, bring in some dry air. It can also do things in the upper troposphere like weaken the hurricane's outflow. We'll look at an image of that as well. These are all things that prevent the cyclone from reaching its maximum intensity. So that occurred early last week. So we stopped the image as it was tracking west-northwestward across the Atlantic. Now let's restart this. And just watch the approach. So the eye sort of re-emerging, looks like a pretty decent storm, but you see that the color of the cloud tops around this cyclone center never really got to those really dark colors that it's sort of obscured by this bar down here. But these really dark colors, the blacks, even the white colors in the interior, are really deep convection or evidence of perhaps deep convection. Very cold cloud tops. This is IR imagery, so you're looking at the energy being emitted from the cloud tops. The colder they are, the deeper perhaps the origin of the deeper this convection is, the thunderstorms are, the more intense the storm. And this never really got back to that nice dark reds and in fact whites and grays that we saw earlier. So it never really recovered. But still a fairly significant storm This time yesterday was around 110 miles an hour or so in terms of its wind, and still tracking off to the northeast. And let this just continue
No,
forward.
go back to that.
Northwest, yeah.
Um,
You can go back, yeah, there we go. So
What happens there is when this was very strong, the eye was kind of in the middle of that cloud mass, right?
Right.
And then
Pretty close.
what
We can go back
happened
a
by
little bit earlier.
yesterday, it wasn't in the middle anymore.
Yeah, if we go back a little bit earlier, just when it was near its peak, that's a nice,
Very symmetric outflow,
right,
going in all directions.
right. The outflow is talking about these
But,
high clouds around it.
but one of the problems even at this time is that I noticed that I didn't make anything, I made a note of myself, but I didn't make anything too much of it, is that the outflow is really not totally symmetric there, is it? There's more to the north side than there is to the south.
Or the north, more than to the south, yeah, I would say that's correct.
You know, you can see the heavier shield, cirrus shields to the north. So there's kind of an asymmetry there, which is actually a little bothersome, because in the really strong storms, you don't usually see that. And so go to the one you had before, by tomorrow.
Right.
And go a little further. Yeah, like there. Now it's really quite asymmetric. And the outflow
So this is center right there.
is really going toward the north, and some of it circling around to the south and east. But it obviously is having a hard time. Now, I looked at the inertial frequency at this particular point in time, and there was actually fairly high inertial frequency in a trough to the west
Okay.
at this point.
Okay, well, let's actually jump to that.
But I just want to point out that it can't push the outflow very easily in that direction. So it was pushing it around that.
Mhm.
And I think the transition to this point may have actually triggered the eyewall replacement. We don't understand why they're triggered, but what happens with these eyewall replacements is I don't think they're random. I think differences in the dynamics that are driving the storm, like clutching on the gas or something a little like that. I think this throws them into a mode where they replace the eye. And I think something to do with this inertial frequency and the very inertial stability of the outflow is causing it to go and replace the eye. But at the same time, it's also making this very asymmetric, and it can't regain its strength because it just doesn't have the freedom to grow the circulation.
Right, right. So just for everyone to sort of hopefully appreciate it, and I'm going to make sure I'm getting this the same way. I think I largely agree with what Greg is saying. The source of a tropical cyclone's energy is really the fact that the air just above the ocean surface aren't thermodynamically in equilibrium. There's an opportunity for fluxes of moisture and heat from the ocean to get into the lower atmosphere that eventually swirls into the tropical cyclone center, and then it's manifests as deep convection as it goes up, and then it spreads out in this outflow layer. So it's gaining energy to help spin up the circulation through that process, but also as the storm is sort of getting rid of its outflow, getting rid of this sort of spent energy, this air is spreading outward from the top of the cyclone. If it has to force itself against some obstacle in the upper troposphere, it's going to have to do work to do that. That work that's done there can't help spin up the tropical cyclone. So if there's anything that's impeding the outflow of the tropical cyclone, making the outflow of the cirrus shield highly asymmetric, you're probably not going to get the most robust storm that you could get.
Another thing I want to point out in this particular picture here, this is what we were just talking to John about. You see on the right side there how the outflow gets pushed around to the north and east, but there's a part of it that's circling around to the south. Now that's not really the outflow, but there's a slight anticyclonic circulation at the upper levels coming around the south side of it. I'm suspecting that anticyclonic circulation works into Florida, and that's what's causing it to meander in that direction toward its own outflow later on.
Okay, so we're talking about the outflow. I'll jump ahead just a little bit, but I don't want to lose track. Let's go to the browser, and I would like to go to this right here. Okay, so this is a picture of pressure along the two potential vorticity U surface. This is what's known as the dynamical tropopause. It's located far up in the atmosphere, and it's sort of a region where we might be able to see some of the outflow from the tropical cyclone. So we're looking at pressure levels here that are on the order of 90 to 120 hectopascals that are shown right here. The cooler colors here indicate a much lower tropopause. So this is the upper trough that's located to the west of the cyclone. You'll see when we look at our current weather map discussions, a trough in the western part of the United States. You can see these are at around 330 to 360 hectopascals, around 350 millibars or so. And then also there's a deep trough that's out in the central, extending from the northeast out to the central Atlantic well to the east of Bermuda. So if we actually go back to 72 hours, so this is kind of in line with what we were looking at earlier. Here's our tropical cyclone at 952 hectopascals. That's at the surface. We can see where the surface cyclone is located. And you see these regions of orange and yellow here, which are associated with rather high tropopause. Immediately just to the west, and you can also see this flow is, there's some evidence of it being somewhat divergent, but it's actually not, it's not really strongly divergent. It's actually out of the southeast over the tropical cyclone at this time. And immediately it hits this region where the tropopause is a little bit lower and the winds are actually in a different direction. So there's a boundary here that's preventing the outflow from the tropical cyclone to, in a very symmetric fashion, expand away from the.
Another way to look at it is that boundary prevents divergent field from happening. So you can't grow, you can't expand something into that region. It hits it like a wall.
Right.
And that's why that flow is just turning from the south and
going to the north. Right, and it's turning and going to the north. It's forming a little jet here, so the energy is being converted to the region of the jet.
That actually reflects back in the storm. The storm is having a hard time pushing it out, so its pressure above starts getting high, and therefore it's hard for it to push vertical motion into the high pressure. The whole thing cranks down.
Right, so it'd be nice if these images were created on a larger scale, and we actually have the ability to do that. We should produce our own. But this is, so here's a tropical cyclone. If we just step forward, let's go 12 hours ahead to 60 hours. Or 60 hours back. This is before current time, 60 hours before 12Z this morning. This is actually pushed a little bit away from this. This was during a time when I think some of the models were still forecasting some further development. But when I look at this, I don't see really at this level, at least, strong divergent outflow from the cyclone center. It's sort of flow that's almost over it, at least on the dynamic tropopause.
On the eastern side, there's a little bit. Eastern
a little bit, right, in this region right here. Right. But here, it doesn't look like it's like a thing just kind of circling around it. Let's go ahead to 36 hours back, just so we can move forward. Outflow is becoming a little bit more expansive, but now you have this feature that's formed just to the south of it, this little upper low that's off the southeast coast of the United States. Maybe that was also responsible for more of a shift in this cyclone instead of tracking, well, couldn't track to the north, but this is helping to maybe steer it closer toward the coast at this point. Again, you can see a little bit of the outflow there, and then it kind of circles around to the south of the cyclone at this point.
Is this the point where it's starting to make a little bit of a left turn?
I believe so. We can go to 12 hours later. Okay. There's a cyclone, and this actually looks like it's in a more favorable environment for maybe it to begin to intensify, but at this time it's also slowing down. The water's over it or a little bit cooler or shallower, so it doesn't up well. A lot of factors that are going on to prevent this, but this would, if I looked at this initially knowing nothing about the cyclone, I said, this probably has a decent chance at least beginning to intensify.
But look at that dark red on the southern side. Is that coming around into South Carolina?
This right here?
No, right there. No, on the south, right in there.
Right here. Yeah, this is, I think, historical outflow from earlier that's spiraling around this.
But what I'm wondering is that getting ahead of the storm to Georgia? This is what's going to make it turn left.
We can go, it's 24 hours, we'll go to 12.
Yeah.
It's moving this region. So, I mean, it's consistent with what you're saying. I'm not sure. It's tricky for me to actually make that link. I know this is a favorable region for outflow to occur. This is an inertially weak region, but is it going to just simply shift toward the region where it's inertially weak?
Well, what happened is the winds became light and variable. And what this region is here, this region is not well observed by radar.
True.
This region is totally a function of the cumulus parameterization. And we know the cumulus parameterizations really make the difference according to Nick's thesis, right? Cumulus parameterization, one makes a difference in the track over another in a lot of things.
Right.
I'm thinking this is produced by the outflow of the storm earlier from the cumulus parameterizations.
Right.
And it's in the ECMWF, but it's not in the GFS. So the GFS.
This is GFS.
Well, then I can't make that argument. But it could be at a different level.
Right.
Or something in the GFS versus the ECMWF. But the ECMWF seems to handle this left-hand jog better.
So it'd be nice to be able to produce these sort of maps. We might be able to in the next couple of weeks. There's an embargo on the data. If we can get that, maybe pot this up for students interested in doing that. It might be interesting to take a quick look at that and compare the outflows, at least on what the model representations of this 2 PBU surface are, to see what the structure is. But the idea Greg has is that because these higher tropopauses, this is a region where you might expect convection to perhaps be favored and outflow to be favored in this region, that the cyclone might be moving in a direction where it's actually better supported in the upper troposphere. So we'll come back to this and look at what, we can stop at, let's say, 0. Just click on that, since that's current time. So here's our tropical cyclone. Here's this elevated tropopause. This is all, I think, in the analysis at least, it's the historical outflow from the tropical cyclone itself. There's still that big wall that's out to its west that's kind of propagating westward and away from it, but now it's just a point of landfall. We'll come back and look at this structure, but let's go to some current storm information, see how it's doing right now. Go to this map right here, and this is from 17Z, so this is fairly recent. You can see the cyclone located just right inland away from the coast. Really strong winds and the circulation around it. In a report that I saw in the Intercept just before coming down here, they're looking at North Carolina. I guess they think that their $3 billion insurance fund is already going to be wiped out, and that they're going to have to, all the residents of the state are going to have to contribute to this, probably the federal relief as well, for the damage that's occurring. So we can see the wind damage. You can see the strong winds, 40-knot winds being reported all over here, all over this region, just along the coastal region. As soon as you get inland, drops down to 35 knots, 25 knots as you go further away from the cyclone center. Very strong easterly winds here, northerly winds here, sort of a flow kind of draining down along the east, on the coastal plains right here, and you have a strong southeast wind. So it's also probably going to create at some point maybe some sort of coastal front, I would imagine. This is kind of what we might expect to see during the fall with the winter cyclone. But it's along this region where we have this convergence of southeast flow off the Atlantic, and it's fairly moist with very small dew point depressions. These dew point depressions aren't particularly large here. In fact, it's saturated at this station right here. It's near Raleigh, Durham. But you have convergence occurring right here. That's where you can expect to see in the radar. We'll look at the radar in a moment. Very heavy rainfall occurring close to the cyclone center and away from it along this region of convergence. Speaking of rainfall, Pete has a loop of the rainfall over the last, is it 24 hours or so?
It starts 0 to yesterday.
Okay, so let's take a look at the accumulated precipitation associated with the storm as it was approaching the coast. Okay, you can see the legend over here. We see the arrival of these eye walls sort of spiraling in. As you get into the red, you're already getting into 6, 7, 8 inches of rain. We'll stop at the end of this next loop and see that we're already at about a foot or so. Radar estimates of precipitation. We're getting into these pinks and purples right here, which are just over a foot of rain or so. And again, this event is still ongoing right now. Most of it's to the well to the right of track as the cyclone comes inland. You can see very close to where the core of the cyclone is. And this rain is going to continue to spread inland. Let's look at a current radar.
I was just looking on the map mailing list this morning. There were some reports that confirm on the order of a foot. There were also some reports that were coming in way high, like 24, 30, 36 inches.
Yeah, I saw that.
They think that those were some temporary sensors that they put in that are either being affected by the wind tipping the bucket, or they're close to water and there's like sea spray and other stuff that's increasing the values more than what they could be.
These radar estimates, in my view, are just revolutionary. They're quite remarkable. You can look at these and get a sense. I mean, you can put some rain gauges in there and it looks a little better, a little more detailed, but this is giving you the essence of what's going on in a big way.
Just be aware with the composites of the total precip that are on our site. If you look at those, every radar has a different time period of accumulation, right? They reset at different times, and it has to do with the operation mode of the different radars. So that's why you'll see, as this thing goes
Look in the
through,
west over there.
they drop off, when they reset.
You still got last week's floods over there.
Yeah.
Eastern Tennessee, Western Tennessee.
The Weather Service site, if you go to the individual sites, they actually show the time period of accumulation if you want to check. And I've got some links to those on the website as well. But just be aware, sometimes, like when we had the big flooding here, the Chicago radar didn't reset for like a week and a half. So like 2 weeks after, Professor Tripoli got, 11.5 inches of rain, it was still showing that on the composite from like a week ago. So just be aware of that.
So let's look at, if we could go to our current radar site. I don't have that actually up.
It's really only been raining in far eastern North Carolina for less than a day,
Right.
right? I mean, it didn't start until late afternoon yesterday. And they already have 8 inches, 10 inches in some places.
Actually, let's go to a close-up, please.
Goes up to the southeast.
Southeast. Maybe it's the middle, right? So I was expecting to see sort of a band of convergence. Doesn't really show up as well right here. You can definitely see the cyclone center. As it made landfall, it took a jog slightly to the southwest, and now it's or west-southwest. Now it's moving, continuing to move more toward the west in the latest Hurricane Center update. So this is just going to move inland slowly. And we have that convergence along the coast, and if it's moist enough, I guess we will see a heavier accumulations in this region, maybe where you see this brighter colors that are lined up right along the coast is where that's occurring.
You know what's unusual in this?
Yeah.
How much symmetry there is in this whole thing to the south and east, because it's coming across the land there where you'd think it'd be much drier.
Mhm.
Yet it's maintaining a lot of intensity on its western and southwestern side.
Well, still, I guess a significant part of the circulation is still over water, and I think this is still relatively flat, so it hasn't really degraded.
But they tend to look a lot more asymmetric of that than by the time you get inland.
But the precursor dew points in the southeast were in the mid to
Right.
high 70s for days on end. So
Okay.
I don't know how deep that is, but probably pretty deep. And no worse off than over the ocean, I would guess.
But if we had a longer loop, to the extent that there was still an eye wall just before it made landfall, one of the really interesting things, and I'll say puzzles for me to think about, is when these cyclones have a nice, well-defined eye, and then once they make landfall, they get into a state like this, you might think, all it has to do is drift right back over water, it's going to re-intensify rapidly. I mean, this does look like a nice presentation, but at least according to the Hurricane Center, the inner core of this rapidly collapsed. And so it would take time for this, even if you moved it over the Gulf Stream or warmer waters, for it to really, it's never going to get back to its healthiest self as was just prior to landfall. It's still a healthy storm, but it's going to take a while for it to really begin to spin up, because you have to really get the inner core structure better defined. And so this is still it's going to be a big precipitation producer. And I think the key things we'll see when we look at the expected rain totals, obviously close to the core of this is going to be high. But you have this already moist air mass that's well to the north of it. You're about to begin going up the slopes of the Appalachians, particularly from Roanoke southward through parts of western North Carolina, western and central North Carolina. That's where you're probably going to see, in addition to this, you see an enhancement of the precipitation right along this region because of the upslope flow that's going to develop. And you're going to get condensation and precipitation processes occurring right in here. So that we're going to see that's going to be a place that's going to be concerned.
I should point out that the main reason it switches and you lose the eye wall structure when it comes on land is it switches mechanisms for the clouds, because once it goes over land, it's really entirely being driven by conditional instability.
Mhm.
It's just being driven by instability that if you lift the air, it continues to go up because it has a lot of humidity. But when it's over water, it's creating that moisture by drawing it from the ocean surface.
Right.
And so it's not conditional split, it's actually mostly stable rain in the eye wall that's being lifted in that circulation. That circulation immediately dies off once it goes over the land.
Correct. You turned off the inner dispersion.
Yeah.
So that's occurred. And a couple other things, we talk about impacts, particularly those of you, I guess it's 141, you talk about impacts. You know, for the state in the last couple of years, and this is not a partisan statement, it's just a reality, they relaxed rules for where they put some of the refuse from mining operations as well as from a lot of pig farms in North Carolina. And they're allowed to let this sort of a sewage of that just sit in open ponds as part of a process of eventually cleaning it out. With these flooding rains spreading across the state, there's a concern there that a lot of this is just going to run into rivers and begin to contaminate large sections of eastern and central North Carolina as this storm moves in and causes this flooding. So there's no barriers for these ponds. So this could be an environmental, I don't want to say disaster, but it could be serious environmental impact and public impact from decisions that were made by folks that are supposed to be responsible for planning. So a lot with this storm and unexpected impacts that you might not have otherwise anticipated. Let's go back to current storm information. Where is it going to go? Well, here's our latest Hurricane Center track. This was at 11 a.m. It shows in brown the sort of extent of the hurricane force winds is estimated. And I think this is perhaps, I'll be frank, an overestimate of the hurricane force winds at the surface. I don't think there are any reports yet of hurricane force winds inland, certainly this far inland. Maybe offshore, there's probably still some hurricane force winds, but this is a rapidly weakening cyclone. The estimated intensity at this time was at 80 miles an hour, so just 5 miles over the declaration required for it to be a hurricane. Tropical storm force winds certainly are being observed over a broad swath. And these are winds at least 39 miles an hour up to about 74. So they extend well to the northeast of the storm into the southwest, and so that's moving on inland. So they have for the next through 00 tonight, so through 7 p.m. our time or 8 p.m. local time out in on the East Coast, there's still being a hurricane, and then after that, it's going to be expected to be downgraded as it moves across the center part of South Carolina to a tropical storm, and then eventually a tropical depression, and then just a non-tropical, post-tropical depression as it moves into Kentucky, and then out to sea, out to the northeast over the weekend. Again, with this track like that, persistent east winds along these slopes of Appalachians, that's going to lead to a significant pileup of precipitation. Let's go back.
I want to mention one thing, that when these things move inland and it switches that circulation, one of the key characteristics of the different type of circulation that's going to happen over land is the cumulus are going to produce density currents at the surface. You don't get that over the water because of the way it's drawing energy right out of the water. So over land, it becomes cold core in the middle, right near the ground.
Right.
And because of that, the winds die off near the ground.
Mm-hmm.
And so this is the reason why the winds are never anywhere near as strong as it loses that eye wall type circulation, drawing energy from the water. The winds will not go to the ground; they'll be up above the ground, right. And it's a different kind of it's now an MCC.
Right.
It's not actually a tropical cyclone.
So for those of you that I guess were in 452 or seniors that took 311 last year, what Professor Tripoli was just describing is this process of Ekman pumping helping to basically decapitate the cyclone circulation in the lower troposphere. You begin to lose that because you have the friction is going to draw that air inward just above the surface. Air is going to rise, but it's in a more stably stratified environment, so it's going to have to be divergent in the lower troposphere. That leads to spin down of the vortex near the surface, and you're left with a remnant, pretty robust
it's the
vortex.
precipitation-induced cooling near the ground too. That
Right.
creates a density current.
So it keeps it, increases the stratification. So that's what's to be occurring there. Let's jump to here for a second. Look at the precipitation forecast for the cyclone. I'm going to go back to rainfall potential right here. And so you can see, again, this is starting. This is starting from the period from 8 a.m. this morning through 8 a.m. I guess it's Wednesday. This is going to be a long period. The storms going to exist. We're looking at amounts again close to where landfall occurred. They already have about a foot of rain in these regions. They're going to get perhaps another 20 inches over the next day or so as the cyclone slowly moves westward. Then it'll recurve northward. But this enhancement that you see right here is in part due to the fact that you have the Appalachian Mountains here. And that as the air rises along the mountains, they're going to begin to increase precipitation amount. So looking at 6 to 10 inches in this region of the orange. And then we saw the track is out to the northeast. These are going to be associated with showers around the circulation as it moves northeastward.
So, but the question becomes with this, why is there so much rain in this storm compared to other storms that hit other times?
I think part of it is the slowness of the storm, the fact that it's moving so slowly. The other part is someone did a study. This is something that's interesting conversation piece. Kevin Reed at Stony Brook University, they released a paper on the impact of climate change on this tropical cyclone. Pretty interesting. The paper comes out just as the storm is actually going on. And what they did was essentially an experiment in which they looked at historical data over the last several decades and tried to figure out the differences in sea surface temperature, water vapor in the lower troposphere, temperature structure. So track that out from hurricane simulations and then compare it with what's occurring, do 2 different runs, current weather run and then current weather run minus some of the changes to key variables that they attribute to climate change. And what you see is a weaker storm with maybe about only 70 or 80% of the precipitation that we're seeing forecast by this model. If that is an appropriate type of experiment to run to say that this, you can attribute climate change to a certain level of impact on this, I'm not certain. I haven't looked at the study carefully enough. I don't know folks that have looked at the paper.
One of the things I see is this outflow to the south type of thing. The fact that the elevated tropopause is reaching up into Georgia. I think that's unusual behind one of these storms. I think 20 years ago, these storms would have just moved northward and they would have got caught in that jet. But now we have that warm bubble to the south at higher levels, and I think that's holding it back.
Right, but in order to get that warm bubble, elevated tropopause, that's related to convection occurring. right? Because that's convection that's eroding the tropopause, making it higher. So there's
I
a
think it's
feedback.
more than that. I think it's, what I've noticed in the past few years is a poleward extension of the tropical tropopause from where it normally is. I think it's not much further north like it was last year, as almost a new climatological feature. I think in another year, it would have been not anywhere near Florida.
It'll be interesting to see if, Professor Reed's results, Stony Brook, show in his model runs that you actually would have a lower tropopause now than.
Yeah,
than
that would be
otherwise.
interesting. And just this last week, when we were talking about the potential event last Friday,
Mhm.
we were noting how there was so much popcorn cumulus all over the place, unorganized, but tent poles everywhere in the southeast US. So that can't help but raise the tropopause a little bit. The other thing about this storm is, didn't it get first dibs on the Gulf Stream and adjacent waters after a warm summer? Because I don't think there's been any other major storm,
right,
right?
that's
So
right.
it's the first thing to skim energy off the top of the ocean surface, and water as well. It's got a really nice advantage that way. The slowness would really impact that.
Right, and any subsequent storms that will go over this region, but it's actually gonna be a really narrow region, right, where the impact is gonna be felt.
Yeah.
If you looked at SST maps, and we can do this certainly by next week, you'll be able to trace the path that the storm followed because of the upwelling that's occurring
Yeah.
under it. So that'll be an interesting thing for next week. We can go back to this plot right here. I think you can use the arrow, back to this one. So this is again the dynamic tropopause, and a couple things I want to point out, and this is more dramatic last week when I showed it to John after Weather Watch last Friday. This, again, elevated tropopause, what we've been talking about, is in part the outflow from this tropical cyclone. There's another tropical cyclone off the East Pacific. I think that's also contributing to an elevated tropopause. But we can step forward with the mouse keys, I guess. For the time, we can just follow this outflow over time. Here's our cyclone. It's going to be moving westward and eventually weakening. We can just step forward in time on this. You see the tropical cyclone, here's the outflow. Notice that the oranges begin to decay somewhat because you have less vigorous convection, so you're not getting as much outflow. And we can keep just going forward with this. Some of this is not being created, it's just what's left, the residual elevated tropopause being pushed off to the side. You can see this eventually gradually weakening. Thermodynamically sort of relaxing back to what it was before. This cyclone is now underneath a weak upper trough at this point. We can keep going forward and just see how this outflow kind of just recycles itself around. So this is kind of interesting that the impact of these tropical cyclones is not going to be just local. We think about the circulation of the lower troposphere, there's an impact on the larger scale circulation. Some of this air is now feeding into a broad ridge that's going to begin covering parts of the central part of the United States. We're now out at hour 108 hours is Wednesday of next week. The remnants have already kind of long gone in this context. And we can just keep stepping forward with this, just watching how it sort of all gets mixed together over time in this broad ridge. So, even over Wisconsin, if this forecast is accurate and we had an accurate depiction of the outflow of the earlier times, we're going to see, at the tropopause level at least, over us, some impact of the elevated tropopause associated with this tropical cyclone.
That's now a tropical
Middle of next week.
going up there.
Yeah.
Basically.
It's feeding into that. Not all this air is from the tropical cyclone we care about from Florence directly, but some of the air that's out over the upper Midwest by end of next week associated with that. So these impacts can have big, the larger the cyclone and where it eventually decays can have a big impact on the tropical and mid-latitude circulation several days to weeks later, and that has an impact on the wave structure at these levels. So it's really interesting impacts to look at, but we're not going to focus on that so much today. That's about all I want to say about the tropical cyclones. We go to the SIMS tropical cyclone page. Greg pointed out just some differences in scale. If we looked at the Atlantic, there are a lot more activity that's going on. You'll see it's the very end of this. This is Isaac, the remnants of tropical storm Isaac, now depression moving through the eastern part of the Caribbean, sort of the graveyard of tropical cyclones this time of the year, but if it can survive, maybe we'll see redevelopment as it gets into the Western Caribbean. I unfortunately forgot the name of this cyclone that made it.
It's Mangkut, I think.
That made landfall in the northern islands of the Philippines. That's going to be sort of devastating for agriculture interests there as well as just public safety, but a fairly significant typhoon. You can compare on this map the relative scales of these disturbances. So this is being sort of a beastly storm. That's a much more intense cyclone. and
It's
larger
considered
scale
a super
outflow.
typhoon.
Yeah.
Right, super typhoon, category 5, and it's gonna be downgraded to a category 4 in the forecast in the next, I think, 12 hours or so. If you go back a few clicks if you're interested in looking at that. But, and the remnants of a storm that went through the Hawaiian Islands, again, their second storm in 3 weeks.
You notice, if you go over to the south, there's actually, maybe, just go back to the first Sims page, there's actually a storm in the South Indian Ocean. What's going on with that?
Can we see it?
Yeah, look at it.
Oh, the investigation area.
Near Reunion, La Reunion, you know?
Right.
This is not the right time of year for it.
Yeah.
This is
more
still their
February,
winter, isn't it?
Yeah, that's right.
Not available yet.
Maybe it's.
You can see the IR, if you hit IR, you can see it. So there's,
Yeah.
yeah, it's pretty obviously a circulation in there.
Right. Like storm, cyclonic circulation
Wow.
again, it's in the opposite direction of that hemisphere. It's in the perfect direction of that hemisphere.
That'd be like a Hurricane Josephine from December of '84 or something, wading way into that part of the season or something.
Yeah, except it's not in the end.
So,
Yeah, right. Had any recently,
True,
it's
that's
like,
true.
yeah, we like have one in the very beginning,
Yeah.
February.
so that's all I want to say about Florence. John, you want to say some
Yeah, some things about the forecast
Yeah.
maybe? Okay. Yeah.
current weather too?
Thanks. No meteorogram today.
Yeah, okay. Right.
We'll just take a look at, we'll look at the continental US, and we'll do it in our normal way. So, well, not surface maps, we looked a lot at the surface. Let's go to upper level map. First, the satellite, yeah, let's go to the visible satellite over the continental United States. So here's Florence, and Florence is of course a major event, and it will be a major event all through the weekend. We saw through some of the other maps that Professor Morgan presented, a number of different portrayals of the broad scale structure over at least the eastern 2/3 of the United States, and then mainly a gigantic broad ridge over this part of the country. And one can almost see the boundary of it to the north and west here in the clouds, and we'll see that depicted in a few other ways. I think we saw lower values of the pressure on the dynamic tropopause over the western United States, and then higher ones over the ridginess. We'll see that reflected in geopotential heights and other measures in just a minute in the middle and upper troposphere. Another of the storms that's kind of interesting is Helene. There's a weak storm called Joyce, I think, that's trying to put itself together, and Helene's over here. And Helene's going to make her way up toward the British Isles by the end of the weekend. It won't be one of those, sort of like the October '87 storm or something like that, because it's not that strong to begin with. But it will have a noticeable impact in the British Isles, particularly in Ireland and the Irish Sea, it looks like. But there's a broader scale extratropical disturbance that will probably exert its influence to a greater extent, as is often the case when these things migrate further north of 35 degrees north.
If you choose to believe such.
Yeah. So anyway, what last thing about Mankut, which is interesting, the storm in the Pacific, is that very often the Pacific typhoons, when they recurve toward Japan, can have a huge impact on downstream waviness in the Pacific Basin in North America, and of course then forecast accuracy at 1 to 5 days. This storm, though, is going to make its way straight across Luzon, northern tip of Luzon, toward Hainan and Hanoi in northern Vietnam, and disappear in the mountains of Southeast Asia. So it's not probably going to have the impact that sometimes these Pacific typhoons do, but it's purely a function of track and how far away at 15 or 12 degrees north, how far away the PV bubble at upper levels, this low PV bubble, is from the jet axis. It's just too far away to have an impact. So one thing I'll say about the Pacific in our own part of the world, the Northeast Pacific, is it's storm-free relatively. For this time of year, it's somewhat, well, not so unusual. A month from now it would be unusual. It's not so unusual now. There's a pretty intense little cyclone skirting across the far western edges of the Aleutian Islands. But that's really the only thing in the entire view. Somebody going to say something?
I'll say this little cyclone.
Oh, yeah. Well, it's, of course, a massive scale. When we want to talk about the scale of it, we win hands down. It's sort of like the Red Sox versus the Orioles.
Oh, that's cruel. That's
Cruel but true.
Yeah.
And when you look at it in the water vapor, it's really nice. You can see all these little swirls on the massive scale of this disturbance all over the place. Hard to find those in Florence, as it turns out. But they're all over the place in the extratropics. And even here, there's a little bit of a wrap up. If this resolution were higher, it would probably be even more spectacular. So that's the one feature in the extratropical eastern Pacific Basin right now. But you can see, even in this picture, evidence of a broad trough that goes all the way down, almost into the subtropics, and then comes back poleward across the northwest United States, keeps us in the southwesterly flow, which is actually maximized to our north and west, but we're in a broad tropical sort of part of the atmosphere, really, when you come right down to it. So let's start looking at some of our upper level charts, Pete. Let's
John,
start.
sorry.
Go ahead.
Oh, as that's loading up, I was just going
Yeah.
to say that it's interesting, not on this picture, you can keep loading up, but it's maybe tropical within the sense that we're really south of the main jet.
Yeah.
Our jets. Surface conditions are nothing like tropical.
No, that's right.
Which is just an interesting economy again.
Very true. And it might only be the characteristic of September and October, because I think it takes a while for the subtropical jet to really find its way back to where it belongs, without episodes of excursion, which we're under right now. So this jet here, I think we'll be able to show this, has mostly a subtropical character to it. Certainly the aspect of it emanating from, we're at 500 millibars here from this morning, emanating from the southern part of the eastern Pacific, and then this is a broad ridginess that sits over the entire eastern half and even more than that of the 50 states. And there's Florence. So you can see that the main southwesterlies at 500 millibars are well to our north and west. But when you look at the region right in the central part of the country, New Orleans is -7 at 500 millibars. Green Bay is 1 degree warmer than that. And you can look around and temperatures are generally between about -5 to -8 degrees C at 500 millibars, all over the huge expanse of 2/3 of the continental US. So, and with absolutely no wind, there are a number of stations that have just a zephyr blowing at 500 millibars. And Green Bay is not one of them, it's 20 knots there, but Des Moines is, or Davenport. So it's light winds prevail in the middle troposphere, and dew point depressions are pretty large at 500 millibars. But here's a broad upper trough. It's taken its sweet time changing its structure overall and making slow progress in a manner like this, sort of a counterclockwise fashion. We began looking at this in class beginning on Tuesday, and it doesn't look that much different now. Although the trough axis of the southern portion of this is now encroaching on the Pacific coast to a greater extent than it was on Tuesday for sure. And the air is extremely cold. This is the coldest air in the northern hemisphere right now, in the middle and upper troposphere. And it's right over the southern part of the archipelago in Canada. So we'll see that in a couple of other portrayals as well. Let's go to 300 millibars, Pete, if we could.
Are you surprised, John, that there's not much in the way of any convection under that trough? It's just not cold enough over the Pacific.
Oh, over the Pacific. Yeah, I am a little bit. It's not that cold, though. I think you hit it right on the head. But when you get that far south off the coast of California, temperatures are like -20. That's not that cold. The water offshore is +10. So, you get about a 5-degree lapse rate or something. Not good enough, really, to kick anything off. Plus, the scale of the curvature is very large. It's a large-scale trough. So here's our 300 millibar map, 120 or so knots, stretching all the way from the border of North Dakota and Manitoba up into just south of Greenland. So that's a pretty nice little jet feature along the eastern edge of this broad trough, which is sitting over Western Canada and the far northwestern United States. And here's the cold pool at upper levels there as well. You can still see cyclonic circulation around Florence at 200 millibars. Can we go to 200 feet?
It's reversed.
I think it's reversed by the time you get to that height. So by the time you get up there, here's Florence. So by the time you get up there, well, it still looks a little bit cyclonic. Yesterday, it was anticyclonic. So that might be a further testimony to its weakening.
Yeah, in a broad sense, I guess it's still, if you go to Florida.
Yeah, that's right. It's still broadly anticyclonic, but right in the core now, and that's different from yesterday. Because even in the core, you could finally see an anticyclonic circulation at this level a day ago. So here's the jet. It's roughly the same intensity. So this may be a little stronger at 200 millibars. So it's hard maybe to say just by looking at a series of vertical charts whether that jet is purely a subtropical or a hybrid of the subtropical and polar jet. But wouldn't surprise me if the identification method we run every day had it as a subtropical jet. It wouldn't surprise me at all. But that's the main feature over the continental United States, aside from Florence. And the broad trough is the feature of interest for us. And can we look at 850 just to get an idea how cold it actually is up there in Canada? It's kind of interesting to see. These are temperatures that are on the order of about -15 is not the, -10 is about the coldest observed value, and it's in the archipelago. So that's pretty darn cold for the second week of September in North America. And Here's a broad baroclinicity associated with the eastern side of that trough. Of course, above that is where the jet is. And so you have places in Manitoba and Saskatchewan with pretty decent cold advection, temperatures below zero at 850. So we might see some of the first snows of the year up in southern or central Western Canada. And that is interesting. If it persisted over a period of weeks and snow started to fall this early, this persistently, that changes the complexion of the potential early part of the winter and late fall for us. So when you get snow on the ground, the daytime is getting shorter and shorter. We all know that here. It's even worse further north. Greater radiational cooling. These are factories for the production of cold air anyway during the winter time. And if they get a head start, well, then we feel that downstream in time. So I like to keep an eye on that. This is the first setup I've seen in mid-September in a number of years where there's a chance for snow at lower elevations in parts of Western Canada, that far south. So that's exciting. Meanwhile, for us, still it's hard to find any substantial wind anywhere. We saw there was just a zephyr at 500 millibars. It's 10 or so knots at 850. There's a stronger southwesterly flow to our west, but that's more along the lines of being beneath the upper jet and on the eastern side of that big ridge, or the western side of the big ridge that occupies the eastern third or 2/3 of the United States. So our weather is going to stay fairly similar from day to day, at least through the weekend, it looks like, and we'll start to look now at the forecast. So why don't we just go to the forecast?
I'd like to recognize a comment from one of our online participants, Ross Lazier, a graduate from our department.
Never heard of him.
Yeah,
No.
I may have seen him once. He says, glad to see the argument between John and Michael continues regarding the total kinetic energy differences between tropical cyclones and extratropical cyclones. There's more. Personally, I think John wins.
Of course I do. It's just in the numbers. The integrated kinetic energy in an extratropical storm dwarfs that of the integrated kinetic energy in a tropical cyclone. Sure, they get the headlines, and sure, they're big and strong in the middle. But how wimpy can you be? I mean, you get a little dry air in there. And
Yeah, but you need area. You need area to get that integrated kinetic energy. Ross.
At least our storms, Ross, are not that sensitive to their environment.
Nice pun, nice pun. And
Okay,
but
so-
energy density, I think we,
Oh, well, that's not fair. I mean, of course, that energy density. It's
at
like
some point.
New York's a better city than Madison just because more people live there per square mile. I think you're
I wouldn't say that. No one.
Okay, so.
But remember the tropical cyclones have their energy at high pressures. right?
That is true.
Near the surface, so there's a higher density in the air. So if you actually use the mass factor in there, I think it's a lot closer than.
So you could sail more ships with the kinetic energy in a tropical cyclone.
Yeah.
You mean, that might be true.
Well, who would want to sail on that? Anyway,
Well, no.
I'm not gonna argue.
So here's our analysis of 500 millibars now colored by vorticity. So an intense vortex, of course, associated with Florence. And here are just streamers of vorticity because this trough has got such a wide, long scale, and there's nothing that's really concentrated in it in terms of a sort of a circular or close to circular vortex structure. And so that's a character. That's just one of the reasons why we probably don't see any organized weather systems with it, because the geometry of the vorticity and the vortex structures matters for their ability to develop weather systems. Remember, we saw on the satellite that pretty large-looking cyclone cutting across the western edge of the Aleutian chain. It's a great illustration of exactly my point. Here's a strong isotropic vortex structure aloft, and that does have potency for developing and sustaining a cyclogenesis event. And that was just down sheer of this, right at the western edge of the Aleutian chain. So let's go ahead and see how this broad upper trough structure evolves. Let's go maybe every 12 hours or so. So this will be valid tonight. This broad structure is taking its time. It's kind of now getting a little deformed by a feature that's headed southward in the northerly flow, right along the Alaska, British Columbia border. And so we're going to see maybe some evolution of a feature in the Pacific Northwest. Meanwhile, the broad west-southwesterly flow with a bit of an anticyclonic curve in it, at least over the Intermountain West, is to our northwest, remains to our north and west. So until and unless this feature makes its progress eastward and southward, we're not going to really see a substantial change in the large-scale conditions that are governing the evolution of our weather. And we won't get a close approach of Florence, which would have the possibility of such an impact, but it's not going to do that. As we saw, it's going to curve before it even gets to Indiana and then head back to New England. So let's go to 24-hour speed.
Florence is way north on this one.
So again, one can see the breakup of this, what used to be sort of a monolithic broad trough on the West Coast, especially earlier this week, into an isolated feature to the northwest of Hudson Bay, an evolving feature over the coast of British Columbia and the Pacific Northwest, and an isolated feature here right off of San Francisco Bay. So we've got 3 different pieces to what used to be one broad trough. This one has the potential to put some clouds in the sky in central California. This one may have the potential to produce some precipitation in the Pacific Northwest, and this one's just testimony to how cold it is in central Canada right now. So let's go one more time, maybe 2 more times. We'll go to 36 hours. And the southern feature in California has disappeared effectively. Maybe this is the remnant of it here near Reno. Here's the feature offshore of the Pacific Northwest. Maybe it's intensifying in northwesterly flow, which will mean downstream in time a stronger trough, most likely. And here we are, still well to the south of the region of strongest flow in the middle troposphere, which is undoubtedly the jet axis. And there's Florence, right near Florence, South Carolina.
It doesn't move very much in 36 hours.
No, it's amazing, isn't it? It's just going to sit there and rain. And
That's almost more stationary than Harvey was last.
How long was Harvey near Houston? I forget. Was it 2 days or?
No, it was 3 or 4 days.
Oh, okay. And Michael, you made the point earlier about how this becomes sort of turns into an MCS in response to one of Greg's comments. And that's a long-lived stationary MCS. Even if that's all it were, you wouldn't want to be underneath that for 36 hours. It's going to be a lot of rain, and it's more than that. Let's go to 48 hours, Pete. And I think this will perhaps be convincing, and we'll go one more after this to 60, so we get all the way through the weekend, but it's going to be unchanging conditions for us, as you can see. Finally, Florence dislodges itself from the coast and is now over sort of Columbia, South Carolina, maybe at this time. And there's very little remnant at all of a southern portion of this broad trough. This feature here that's invaded from the northwesterly flow and developed as it's come is more intense. Probably when we go to the surface, we'll see late in the weekend some development going on in the Pacific Northwest, Panhandle of Idaho area, that's my guess. Okay, so we'll go one more. Let's go to 60 hours. That'll get us to the end of the weekend. And even through the end of the weekend, we see no disruption of our weather in the southern part of the state by virtue of a progression of the jet axis to our south and east. That's not going to happen. So we end up with a very nice weekend. Conditions will persist as they are now throughout the whole weekend and probably into the early part of the week. Sudden collapse of our upper vortex over the Pacific Northwest, undoubtedly suggesting that anything that does develop in the lower troposphere in response to its incursion is going to also weaken. And then here's maybe the front edge of really cold air. Let's go to 850 millibars at this time, Pete, even though it's jumping around a little bit. So yeah, that's about right where the front edge of the really cold air is. And that's air that's on the order of -10 or colder at 850. So this is now air that's colder than what's already there, and it was already pretty cold to begin with. So there's been an invasion of even colder air, or maybe even a production of colder air at 850 over this period of time. But it's poised well to our north, and with very little southward movement, we don't really run the risk of ever tapping that in this event. But right along the gradient and downstream of the weaker part of the upper trough that was over the Pacific Northwest earlier, there's a little bit of a development going on near Lake Winnipeg by the time we get to Sunday night, which drags really warm air into its core, and then it's fueled perhaps by conversion of the baroclinicity of that strong temperature gradient that's in central Canada. So that's probably going to be the feature that has something to say about our weather into Tuesday or Wednesday, but it's going to be slow moving and slow to develop. That might be the beginning of it. So let's now go to the surface charts, and we'll start at 12 hours and see if we just follow some of these features that have some relationship to what we're seeing along. Widespread but light precipitation over the Pacific Northwest, I think, is related to that upper feature that we saw starting to emerge in the 500 millibar vorticity. Pressures are really high and temperatures are cold. Here's the 540 thickness line. So we've already seen the cold temperatures, but low thicknesses. There's some snow up in the chain of lakes in Canada. That's exciting for me. There's even more there. So let's do it. Let's get some more in there. Okay, let's go to 24 hours, please. Continued snow. I'm going to guess this will be wet snow, so maybe it doesn't count. But a little bit of snow up there in central Alberta. And then we went from 1,011 to 1,008 to 1,008. maybe slight consolidation of the precipitation shield associated with that weak cyclone off the coast of Washington and British Columbia. Let's see what happens at the next time. 1007. If this were a little bit later in the year, this would be the kind of thing that gives Seattle a snowstorm. You know, you got a storm that develops offshore in northwesterly flow along the British Columbia coast. The cold air funnels in through the Fraser River Valley and you get snow. Not this time of year, it's not cold enough, but it's exactly the right setup. But the storm is not intensifying very much. And I think this was the time where it looked like the upper wave was strongest. So 1007 might be the time of most intense development for this weak disturbance. It's still raining in the Carolinas. And let's go to 48 hours. 1005, a little bit more development and just a miserably rainy weekend in Seattle. And as Maria pointed out in our class yesterday, they don't start school at University of Washington until the last week of September for a good reason, because the weather is so nice and it's not nice for another 6 months after the 1st of October that you don't want to give up any of those days. But son of a gun, one of their last weekends, perhaps the last weekend of the recess between sessions at the University of Washington will be occluded by rain, which is kind of miserable for them and unusual. It's an unusually wet time of year. When it's wet there, it's unusual that it's this time of year. And you can see this 1001 millibar low starting to emerge in the high plains states. And it brings our southwesterly flow associated with it, even in the lower troposphere, closer to us. We've been rather immune to having substantial winds throughout this whole period. And let's go to 60 hours and see what we get then. We went that far. So complete disappearance of our cyclone over the Pacific Northwest as a separate entity, but a sort of an emergence in development of this feature right over the Lake of the Woods or International Falls. 998 precipitation shield, unsurprisingly, is concentrated along the strong baroclinic zone because the circulation there is frontogenetical, and that's going to help to produce precipitation in that region. And yet there isn't much of a southward extending either boundary of any kind of thermal structure, nor is there any particular evidence for a substantial amount of water vapor and organized precipitation in the southern side of this developing storm. A couple of showers here to our south and southwest, maybe even one over us as the model puts out something on a sort of a grid box scale here on Sunday night. But that's probably passing at a very low probability of it hitting wherever you happen to be. Continued heavy rains in the Piedmont of the Carolinas, and the storm is finally weakened now to 1006, which is still below standard sea level pressure, so it's still a disturbance of note. So I think I'm going to stop there. Now we probably have to see what happens to this baroclinic zone. Let's go a day ahead of this speed, so let's go to 84 hours.
And if we could even go to a week ahead, I'm just curious.
Yeah, we'll do that too.
Yeah.
Precipitation does slide southward with the baroclinic zone, but the storm races off to the north and east. I'm not even sure it's the same one, but it's 24 hours later. It probably is. 1001 on the southeast side of James Bay in central Quebec. So that's a nice looking storm. Small, compact little disturbance. And its cold front dragging back to the south and west is likely to be a factor in our weather here on Tuesday, although right at Monday night, it's still to our north forecasted precipitation. See what happens at 12 hours after that. So that'd be 96 with it. Wrong level. And there's the storm. It's weakened. Its frontal zone is kind of still extended southward across us, but it looks like the precipitation is going to have somewhat of a difficult time if this forecast is valid. Somewhat more of a difficult time staying together by the time it makes it all the way into the southern part of the state. So I'm not ready to say it's going to rain here on Tuesday. I'll just say the chances will increase from 0, which they are right now, to something well over 50 or 60%. That's about it. So what did you want to do, Michael? See, like a week ahead?
Yeah, so 168.
Okay, let's go out.
I think there's going to be a big change.
So 168 is a week from today. There's a pretty sizable cyclone. Undoubtedly, this feature has had it rain over us for the late part of the week. If we're on the warm side of it, though, that means that the conditions of high, dew points over 60 or so and temperatures, 70, mid 70s to low 80s that we may experience this weekend would probably prevail through much of the week. But as you point out, Michael, you're right on. very strong thickness contrast coming across in the wake of this cyclone. So this is going to be a region of pretty strong cold advection. There's the 540 line, makes its way into northern North Dakota and far northwestern Minnesota. So we'll cool down by the time Friday afternoon into Saturday comes along next week if this forecast verifies. But the coming week,
Explain
will be a
why,
lot like,
what's the 540 line?
oh, sorry. 540 decameter thickness. So there's a thickness between 1,000 and 500 millibars that's routinely measured. And that line is usually used as a rain-snow boundary. If there's precipitation falling and the thickness is lower than that, there's slightly more than 50% chance for the central U.S. that you'll get snow as opposed to.
In kind of DJF. later
Yeah, in the
season,
winter time. So it's not really got more
But
significance
if,
than
in
that.
240, Pete, if we could, all right, that's.
Here's the same time at 850 millibars. And what I'm looking for there for snow is temperatures around 0 or -2. I need that. And I'm way out of the range of that. So that's the light blue. But here's a strong cold front coming right through the southern part of the state at a mile above the ground. That front would have been sort of in Kenosha. And by the time, you get to the surface, it might be just a little bit further to the south and east into Chicago. So the front's making its way through by Friday morning, and it's pretty chilly behind it. These are fall-like temperatures for sure for next weekend is what it looks like.
And since we're this far out, we should go to 180. Just to, I know people have to leave. I don't want to hold up. And also, I guess another
Go
class.
180?
180 at the surface, or
180 surface. Let's do
yeah.
that. Just for you.
It's
Have
gonna- it's
something
gonna
you've got in mind.
No, just
Ooh,
the cool.
yeah.
That's gonna be nice.
That's cold. Nice light northerly flow, cold temperatures, cold air advection, all the precipitation to the east, beautiful clear skies, great apple picking weather, and you'll probably be like to be out there.
Could there be a killing frost in there for us?
Let's see 850 at this time.
Should go pivotal surface. We can get the.
That is that's +2. So I don't think so, not here, northern part of the state.
If you could have
It's a real
pivotal
risk.
and the surface 2-meter temperature.
At
And go
6,
to-
no, at 12 Z.
So that's 0Z. You go to 182. Ooh.
35.
All right, let's go the next night when the winds have died down.
Then the anticyclone would have slid even further southeast, yeah.
Yeah, so already warming up.
So that's gonna be the cold morning, Saturday morning. 35 degrees,
That's a
maybe.
frost. It's not. killing
Yeah, it's a frost at your house, for sure. You got a frost at your house coming, but maybe not here in the city. so. Well, thanks, Michael, for an excellent discussion of the hurricane.
Thank you,
and for,
John.
For all the great
Forecast.
questions, Greg, thanks for all your comments, and we'll see
Pete.
you all next week.
Yeah,
And
Pete for
thank you,
driving.
Pete, of course, for driving so expertly as always.
Andrew Winters says hi too.
What did you say?
He said hi. Ross also followed up. He said, thanks, Pete, John, and Michael. Good point about.
141
Michael,
classes
and-
start
and
10 minutes.
This is Greg, but I still think John wins.
Bah humbug.
Yes. It's not hard to think that.
Yep, so you can- is it inside?